Hey everybody, this is Mark Hammonds from Mobile Tuts Plus, and this week I'm going to be talking about memory management and the iPhone SDK, and specifically I'm going to be responding from a question from Dan on Axit Patel's post, iPhone SDK, Working with the UITableView Class Part 2. In that question, Dan wrote, it was actually a two-part question. The first part was, in order to fill the images array, you create a couple of UI image views, but you don't release them later. Is this okay, or did you just forget to do it? And his second part of the question was, why do you create the dummy arrays anyways? Couldn't you just say self.sitesArray equals NSString, etc.? Or is there reason to do it the way that you did? So I'm going to answer both of these questions. And for that, let's take a look at the code. So this is actually the section of Axit's code that Dan is referring to. Now, as you can see, what Axit's doing here is he's declaring this group of UI images, then he's assigning that to an array, then he's assigning that array to an internal data member array, then he's releasing the array that he allocated. Now, Dan's first question is concerning this block of UI images. He wants to know if there's a memory leak going on here because you're declaring these UI images, but then you're never explicitly releasing them later on in the code. And the short answer to that is that no, there's not a memory leak going on here. Now I'll explain why, but it's going to take a couple steps for me to get there. So to begin with, notice that this image-named method looks a little strange. It's not being called on an actual instance of an object itself, but rather on the UIImage class. So what I mean by that is normally when you're sending messages to objects, you'd see something like active in this UIImage instance, and then any number of methods that can be sent to it, messages that can be sent to it rather. But that's not the case here. It's being called on the actual class itself. And if we look at this in the documentation, you can see that this is actually a class method of the UIImage class. It's not an instance method. Now the difference between the two in code is actually always pretty clear because you're seeing a message passed directly to a class. And if you're looking at this in the documentation, then the dead giveaway is the plus sign. Whenever you see a plus sign in a method declaration, then you know that that is actually a method of the class itself and not of an object of that class. So for viewDidLoad, for example, up here, you see that it has a minus. That's because it's an instance method, it's not a class method. In any case, in the documentation you also see that this is going to return a UIImage pointer, and that's exactly what we want here. And so the only remaining question is, how is that handled in memory? And the answer is that this class method is following a very common design pattern in both Cocoa and Cocoa Touch, where a class returns an instance of itself, and that instance is auto-released. And because it's auto-released, it's going to be drained from an auto-release pool later on, and you don't have to worry about releasing it explicitly in your code. Now that's really handy for a lot of different cases. When you just want to quickly create an object, you don't really care when it's released or how long it stays around for, as long as it's there right now when you are working with it. It works out really great. But there are times when it's actually quite detrimental as well. If you create auto-released instances of images, say, in a run loop that's going to iterate 60 times a second, you might want to make sure that you're able to release those at a very specific time in the future, rather than just trusting that the auto-release pool will take care of it on its own to prevent your memory footprint from growing too large. And the way that you would do that is you would actually declare the image without using the auto-release convenience method, UIImage and then you could use any number of the initialization methods that are available, init with data, contents of file, CG image, etc. And in this scenario, you would actually have to release this later by saying active release at some point in your code. Otherwise, you would have a memory leak. Now there's actually another potential pitfall with using auto-released objects, and that's if you know that you need that object to stay along for longer than the auto-release pool itself is going to exist. So you know the auto-release pool is going to try and drain this object out of memory before you're done with it. And in that scenario, what you would actually do here is you would say retain, and now you could use the same convenience method, but you're saying, hey, I want to take ownership of this and I want to increase that retain count by one more in memory, and I'll tell you when I'm done with it. And if you're not sure when the auto release pool is going to take effect, then this is another way to kind of prevent yourself from running the risk of it being drained before you're done with the object you're working with. And here again, like before, you would actually have to manually release that object. Now normally I actually wouldn't recommend doing this, because if you know you're going to have to manually release an object later, you should probably just allocate it and be the one to allocate it to begin with. But it is useful to know. There may be instances where you don't have that option for whatever reason, and you do need to have it in the auto release pool as well. So there you have it. Okay. So I just told you that this is a common Cocoa and Cocoa Touch design pattern that's used with class methods. Now let me show you what I mean. There are a couple that you're going to use all the time, and one of those is NSString. So when you're declaring an NSString and you say NSString message equals, you can actually use the same design pattern to create an auto-released version of NSString that's returned. So NSString string with string is the most simplistic. Hello world. Okay, so what I just did here is I used the NSString class method string with string to return an auto-released copy of NSString and assign it to our message pointer. Now this is actually not the best example, because this method could easily be done instead with hello world, just the shorthand @ sign. It's actually going to do the same thing. It's going to return an auto-released version of itself. However, a more useful one might be string with format. And I use this all the time when I want to take a number of variables or other objects and interpolate all of them into one string object. So for example, I could say the answer is %d, and then I could pass in 42 or any other integer there. And this format specifier %d is going to say, interpret this as an integer and interpolate that into the string, so what's returned is an auto-released version of NSString that reads the answer is 42. You can also pass in other strings, which is kind of nice. So we could do %a, %d, and this is the format specifier for an NSString. And then we could say the answer is over here, and you'd get the exact same string formatted slightly differently. And again, this is just a really useful method for a lot of different cases you might have when you need to interpolate variables within strings. Alright, so the last thing I want to show you with regard to this particular section of the code is how would you set one of your own objects to auto-release. And I'll use NSString again as my example. Alright, so that's how we would normally declare it, but instead of ending there, we're actually going to add on the auto-release keyword, and that's how you would do it. This method will actually add the pointer returned here to the auto-release pool before it's assigned to your message. So now you could create your own auto-released object, and you would definitely want to do this if you were creating your own object class and you wanted to have that class follow the design pattern where it's going to allocate it into memory and then return an auto-released version of itself. So that about covers this section of the code. To summarize again, there's not a memory leak occurring here. Instead, the objects are being auto-released and you don't have to worry about them later. So let's move on to the second question that Dan had, and that was why not simply assign this array in line, why create an array and then release it a few lines later. And I guess what he means is to do something like this. Self images array equals an sArray. See, we're going to do the exact same thing we just talked about, where we say array with objects, and then we could actually just assign the same objects he did above, active AE, audio, mobile, etc. And this would do the same thing that this line does, only it would do it in line with fewer lines of code. And there's nothing wrong with doing it this way, there's nothing wrong with doing it the other way either. It's really just preference, so long as you keep in mind that using this second method is actually creating and allocating the array somewhere else in memory that's going to be in our auto-release pool and retained there, and it won't be released until that auto-release pool is drained. So if you're mindful of that fact and it doesn't really matter, then sure, do it in less lines of code if you'd like. But if for whatever reason in your scenario you do want to have explicit control over when that memory is allocated and released, then maybe you'd want to do it the way that Axit has already done it and allocate it on your own. It really just totally depends on the context of what it is you're writing. In this scenario, I think you could easily do either way. It wouldn't really matter much, if at all. I would, however, like to address a few more things with this particular method, and the first thing is the use of viewDidLoad at the very end. I wouldn't recommend placing viewDidLoad at the end, and in fact I would suggest that you always place it at the very top of the viewDidLoad method. The reason for this is that you have to remember that viewDidLoad is an inherited method of another class. So there could be a very complex class hierarchy between where you are and the class at the very top, the base or root class, and there could be a number of different things happening in the viewDidLoad methods of those other classes that your code actually depends upon and needs to have already occurred in order for your code to execute correctly. In this case, it actually doesn't make a difference, but in general, the safest thing and the best practice I would recommend is to put this at the top so you're sure that all the other objects or classes rather up the hierarchy have had a chance to call that method, and then your class is good to go as well. Alright, so the last thing that I want to address here is the use of viewDidLoad at all for this particular section of code. It's actually very common. You'll see people doing this all the time. They'll throw in, basically anything they need to have happen after or at when an object is created in the viewDidLoad method. But in reality, if you look at what's happening, this is all data related. You're creating a list of sites, you're creating an array of the images, and you just want to make sure that that's there when you're using your UI table. But why put it in viewDidLoad? viewDidLoad is more related to the interface, and after the interface is in place, okay, now we want to maybe put an affine rotation to one of the labels, or we need to hide a view and show it later on, or something like that. This code would actually be better placed in the initialization, the designated initializer of this class. So for the table, this class is actually a subclass of UIViewController. And if you open up the documentation for that, you should be able to see that init with nibname, this is actually the designated initializer for that class. So if you were to subclass this method instead, you could put all of these data declarations there, and it would be a bit more of an elegant way to handle this particular setup. In general, anything that's data related or data model related, you put in your initialization routine, and anything that's view related, manipulating the view after it loads or anything like that, you put in your viewDidLoad method. So I won't go into the details of how to actually implement that. I'm not going to show that here because this Q&A is actually getting rather long, but I will just put that out there as a note, and you can mess around with it on your own, look up the docs on how that might be done. Or better yet, if you'd like to see an example of how that's done, submit a question to mobile@tutsplus.com or send a question over Twitter, mobtuts, and I will try to answer that in a future Q&A. So that's really it for today. I hope you've enjoyed this. I hope it's been useful to you to get a better grasp of how memory management works in Cocoa Touch. And yeah, leave any comments or questions or suggestions you have in the comments section of this post. Thanks, guys. See you next week.